math lovers, welcome to notes number 20, lesson 1.2. This is our second day of working on linear equations with one variable. I picked out two problems for us to do today. In the first one, I want to find the x and the y-intercepts. All right, so you know from your Algebra 1 class, to find the x-intercept, you let y equal 0. And to find the y-intercept, you let x equal 0. So let's plug that right in. So first I'm going to say let x equal 0, and I'm going to go ahead and solve. So y is equal to negative 38 plus 5 times the quantity, 9 minus 0. Well, this is easy now. I just have to figure this out. Y is equal to negative 38 plus 45. So my y value is equal to 7. So my ordered pair that I would have would be my x value would be 0 and my y value would be 7. All right, we're going to do the same thing. Let's let y equal 0. And so let's put 0 in for y. So 0 is equal to negative 38 plus 5 times the quantity, 9 minus x. All right, just have to clean this up. I'm almost done. This is the hardest part. It's over negative 38 plus 45 minus 5x. Let's get our like terms together. So 0 is equal to negative 7 minus 5x. I've got to solve for this x. Let's bring the 7 over. Actually, let's bring the 5x over. So 5x is equal to negative 7. X therefore is equal to, hold on, I messed up. This should be a positive 7, right? Positive 7. Haste makes waste. There I am, going too fast. I made a mistake. So that should be 7/5, okay? My ordered pair there, my x value is 7/5, and my y value is 0, okay? So there are ordered pairs. Find the x and the y-intercept. And of course, you know, you could definitely do that on your 84s, but I am old school, kind of vintage. I like to figure it out in my hand. All right, second one over here, I want you to solve for x. All right, notice that as you stare at this problem, 103, you're going to stare at it, you're going to see not one, not two, but 3 x's in your equation. This is not your usual problem. You're going to have to figure this out. So let's start by distributing. So let's see, I've got negative 2ax plus, let's see, 6x plus 18 is equal to negative 4x plus 1. All right, well, let's get all the x's together. Negative 2ax plus 6x. Let's bring this 4x over, so plus 4x. Bring the 18 over, that's negative 18 plus 1. All right, so this is going to equal negative 17. Man, that's a lot. So let's see, negative 2ax plus 10x equals negative 17. All right, kids, now I'm trying to solve for x. I want my last line of this problem to be equal to x is equal to something, right? I'm solving for x. I need to get the x by itself. Is there a way that I can get these x's together? These are not like terms. I know you know. Yeah, let's factor. All right. So x times the quantity negative 2a plus 10 is equal to negative 17. Oh, that's awesome. Now remember, this term and this term, they're connected by multiplication. And the opposite of multiplication, you know it, division. So x is equal to negative 17 divided by negative 2a plus 10. And there's my answer, right? There's my answer. Now, stop and think. All right, or do I have any restrictions? Is there any value that a cannot be? Right, yeah, negative 5. So a, remember, cannot equal negative 5. Now, I know, oh, no, sorry, positive 5. It cannot be positive 5. Again, I'm racing. I'm trying not to make this video too long, and I made a double mistake. You take your time, my kids. Take your time. I know that you cannot put the 5 in there. I know you cannot put the 5 in there for a, but if they do ask you specifically about restrictions, then definitely that's something you gotta go ahead and take care of. All right, have fun with your problem set.